Today is gonna be a bit shorter after the long mess that was the last episode. And despite that, we didn't even cover all the necessary topics last time. So it's hard for me to really concisely put everything together in a stream form. That's the downside. Yeah, today's topic. For one, I want to expand a bit more on nullability. This is mostly a feature of the newer C# versions, though there's a bit of information in there maybe for a framework as well. And also show you some more attributes later on that you will probably come across sooner or later while programming. They are fairly common, or at least useful enough, so that you might want to know they exist. Going back to our roots, let's quickly write some code. String and int. We have two different variables. One is a string, one is an integer. Strings are reference types, integers are value types, which means that, generally speaking, this variable simply contains the address on the heap where the data is actually stored, while this is the actual data directly on the stack. So we start on the stack, that's where our variables are located. This is the value directly, just an integer number, whereas string would be on the stack only in form of the address that we have to look up in the heap, a different part of the memory, and that's where we find the actual string that we want to store. And because of this subtle difference, reference types can receive an address that doesn't exist. Literally the binary value 0, just zeros as the address. And it has a special name in programming. It's null. Value types cannot be null because they are a value in of themselves. So null doesn't make sense. I can set the address, in the stack where we store this variable to just zeros, but this has the meaning of the number 0. Whereas setting it for a string or any other reference type would mean we are storing an invalid address. There is no data to reference. There's one level of indirection, which is why we can invalidate some data, so to speak. And null can be sort of useful in that you might want to have a distinction between, do I have a value or do I have a no value? Because even an empty string might be a value. Just because there's no text in there, that still means there's a string that is simply empty. There are no characters in there, but this is a valid string still. Even an empty string is a valid string. And maybe sometimes you want to distinguish between, do I have a value at all or do I have nothing? Null. Which gets a bit more tricky with value types because every value we can put in there is directly a value. A 0 is a valid number. So we don't know if that's really a number that exists or not. And so for value types, there is a sort of workaround that lets you distinguish between, do I have a value or do I have no value? And to do that, I can do this and change the type from just integer to a nullable integer. All I did was put question mark in the end. And you might remember question mark is used quite often when you interact with null. Well, actually, it's also used in other cases, but we've seen that happen already in cases where if I use a dot operator, I mean, it doesn't make sense here, but okay, let's just write a simple example class. Public class example. And this has a method public void do stuff. Not doing anything, but do that. And if I go like this, I store an example variable, also reference type, which could be null, of course. But now we actually fill it with the address of a valid example we just constructed. And I can go example.doStuff, and I call that method. But if this is null, well, this would result in a null reference exception. I'm trying to execute the doStuff method on an object that doesn't exist. There is no object in the heap that I could apply this code to. I mean, technically it's empty, but you get what I mean. That's a null reference exception, that's a problem, and that's why my code is currently highlighted in blue, because the compiler is smart enough to know that I specifically told the system this is null, and I directly called doStuff, so this is definitely gonna be a null reference exception. And that's where we can use the question mark operator, the null coalescent operator specifically, question mark dot, which means first check if example is null, and if it's not null, either like this, or if you're using .NET Framework, you can do this, then call doStuff, only if it's not null. Or if you're using the framework, not the new stuff, you could also just write example as object, which is the opposite of is null. By the way, if you're worried about performance, because you know about pattern matching, this code here, not example as null, results in the exact same IL as example as object. Personally, I don't like it. I prefer the not is null, makes more sense to me, but doesn't matter performance-wise. And if you're in the newer versions, you can just write out like this, and that's nice. Going back to the original, we first check if it's null, and if it's not null, then we call the method. And we can simplify that by just doing doStuff with a question mark. So question mark dot means first check the data on my left, and if that's not null, then do the dot operation and proceed in the chain. And you can chain those together. If doStuff gives us another, let's say this actually returns a value, let's be simple, string. I could do like that. And I would check is example null? If not, call doStuff, and that gives us another string back. And if that string is not null, then try to get the length. But you also notice the same structure appears here as above. I just used a shortcut that would automatically create a variable for me that the result is stored as, or stored in, and my system automatically detected this could technically be null. And in that case, this would not return an integer value. If example would be null, like it is right now, or the return value is null, then there's nothing I could get the length of. There's no way I can get an actual index length. That makes sense. And so what I get instead is a nullable int, a special variation of int that includes the option for null, for there is no value. I don't have any data. And what that basically looks like in the background, what we have there is, I'm simplifying now, but no, it's static. We have a struct. I think it was called something like Nullable. T, where T, oh, out there, where T struct. I think it's like that. So you can only store value types. And then you have public bool null. Well, the null has value, It's value and public t value, roughly like that. And instead of storing integer, we would store a nullable, oh yeah, int. And then you can check, does it have a value? Yes, no. And if it has a value, you can extract that. So the same variable can store the information itself, what you want to store, and the additional flag of, do we have a value at all? Whereas with reference type, you just have, is it null? Or does it have a value? And if I remove that, we can now use length itself, which isn't an integer anymore. Length, just as an int above, is not integer directly, but nullable of int. It's the special struct that we have. And so the interface has value, gives me the information, do we have a value? And I can go length.value to get the integer value directly. And actually, let's go back to the code above and change this to an int. Let's ignore the example code for now. I'm just going to execute this. There shouldn't be any issues. No errors, no exceptions, nothing happened. And I would just store a 0 once this code is done. I can, however, also put a null in here. Well, actually, let's put a breakpoint here. Let's try that again, just so you can see the values maybe. So length has value, is true, as you can see, because we have a value, it's a 0. And once we extract the value from here, we just have 0 as an I. That's correct. As you can see, the type is nullable of generic t. And that's because the original struct also is called nullable. I pretty much just recreated the structure so you can see it, but that's the original, at least as far as you can see it. I mean, the internal setup is a bit different. It's a special type after all. Let's retry that with null. This gets a bit more fun. Length as value is false this time because we don't have proper value. And if I now try to read the value, we get an exception. An invalid operation exception. I try to access a value that doesn't exist. So, similar to null reference exceptions, only specific to nullables. I don't think I've ever tried to make a nullable like this. This is the official nullable. Can I actually? I can. But it will just retry this. Okay. New. It's trying to recreate the best this. Okay. Oh yeah, I've never done this, it's just pure curiosity. Okay, there's no issue here, it accepts it, and it just stores the values as they are. So yeah, that works too. Not sure why you would do that, but we can. But this is the simple way. You just have a type, and similar to arrays where you put the square brackets to indicate that this is now an array that stores data of this type. You can do a question mark, and now this type is one that includes the option of no value at all. Which also means I can't do this anymore, and my keyboard layout changed. And this doesn't work anymore because an int is not an integer value anymore. we can't be sure that an int has a value. So we have to do dot value, and we should probably check beforehand if it's null or not. But we can do other things like pattern matching, that still works. So an int is int b. This is fine. This will check if this has a value, and if it does have a value, then it will store that in b. So as far as the normal rules for reference type goes, you can apply them to nullable types as well. So things like this pattern matching. Or is null, you can also do this. This will work as if an int is normal reference type, only it's not a normal reference type, it's specifically a nullable value type. It's a bit weird like that. But that can be useful in certain circumstances, where you want the ability to invalidate a value or indicate that something doesn't have a value at all. That same idea can also backfire a lot. If I want to write my code, having to constantly check if a variable is null beforehand and determine the best behavior for that has been the bane of a lot of programmers over the years. So what was it, like Nullability or null was a mistake, like the creator supposedly famously said? There was a talk like that, I can't remember it. Yeah, null. Personally, I do like the ability to set something to null. I do like null as a concept, it's useful to me, but it's definitely caused a lot of frustration over the years as well. Because of the assumption that something is real, I can use it. And just using it in my code. And only when running it sometime later realizing, oh, I didn't get a value at all, I got just null. And now I have null reference exception, I have to track that down. Especially if you have poor logging, this can be painful to impossible. So having some kind of way to assist you in determining, is this really safe to use? Do I have to check for null first? Can I be sure that it's not null? The ability to keep track of that is definitely helpful. And in .NET Framework, that's difficult without external tools. Now, I've mentioned that before, I use ReSharper, and there are special annotations I can use, attributes I can use to mark certain variables as these are definitely null, this is not going to be null, and all of that additional useful stuff. And the external tool will provide me with that information, but not the compiler itself. So I don't have really full safety. It's useful, definitely has been useful so far, but there are limits. Now luckily with .NET, the newer versions of C#, we got some new features surrounding nullability for this whole tracking of is it null, is it not null, safety around null. And they are now integrated into the language and into the compiler as well. So I can be sure that when I write a new program now that null and not null are very clear, usually. The big change can be done if you open the CS project file of your code. This is the CS project for my current project. We can add one simple property. We can enable Nullable. It's off by default. In a project, you have to specifically enable it. That's for backwards compatibility. If you try to upgrade an old project and suddenly this feature is enabled, it would break stuff a lot. Probably. Depends on what exactly you are upgrading. So by default it's off and you have to specifically enable it. If you create a new project, it's likely already placed in here. Nullable, enable. And what this does is right now give me a warning for my code. Let's remove this for now. Let's just compile this. And look at the warnings here in my code. Now, this we're going to ignore as well as this. Assigned but values never used. This is just because it's example code. We don't care about that. This is the interesting one. Converting a null literal or possible null value to a non-nullable type. It behaves as if string is a value type that cannot store null. Like, this doesn't work. It's almost like this. If I try to compile this, it's complaining specifically as an error about this line. I can't store null in integer. Integer doesn't have the concept of no value. It has to be the nullable int. This works. But for my code right now, it's only a warning, but it's basically the same issue. I can't store null in a string. Because with nullable enabled, the compiler will apply the same rules it applies to value types to reference types as well. You can't just store null. The actual runtime, C# itself, the framework underlying systems and whatnot, they still have null as a concept for strings, but the compiler prevents you from using those features. It will block you off from that. I cannot store null in a string anymore. Even though technically that's possible, the compiler will not allow any code that uses that, let's call it, feature. And I can even be more strict about it by adding another property. It has some other functions as well, but in my case I care specifically about Nullable. This property just makes it so that the compiler changes from merely warning me to making it full of error. Difference being, a warning is just listed in my output here, and I have to read it, but the compiler will still do its job and finish compiling everything. I could still run that as a program. An error means the compiler will just abort and will not finish creating a program. So you have to fix it before you have any program to use. Which is probably a good choice if you want to enable Nullable. Like maybe you have an old library and you want to upgrade. You can activate it first to see how many warnings do you get, how much work would it be to change, and then maybe don't change immediately, do that sometime later and just leave it as warnings first. But once you commit to the change, put it in as an error, so you have to use the feature. But this might be an issue if I do want to use null. Maybe my program logic depends on this, and refactoring everything to completely remove null from my code is too much work. There's a workaround for that. And it's not really a workaround, it's the same we did for integer. We can simply add a question mark after the string, and this now marks it as nullable. The context is just a different one. For integer, it's because we need to wrap the integer itself inside another type that allows us to switch between the state of we have a value and we don't have a value. Because integers and the underlying runtime do not have the option of null. It doesn't exist. So we have to wrap it and combine it with a flag that says, do we have a value or not? Can I treat this as null or as a value? Whereas with reference types, the underlying runtime does understand what null means, and the compiler just prevents us from using it. And using question mark here is not wrapping it in another type, like integer, that adds a flag. It will simply allow us to use the runtime feature, and the compiler simply doesn't bother with the null checking anymore. So it's a slightly different context, but they look the same now. It's either, do I have a question mark after the type? In which case I can store null. Doesn't matter if it's a value type or reference type. Or I don't have a question mark here. and then I can store null. Quite simple. So with the new system, they look the same, behave sort of the same. In the backend, it looks quite different, but you don't really have to care about that. And this opens up some interesting possibilities. For example, we have right now this doStuff method that returns a string. But it says specifically string, not string question mark. So if we ignore this code now and go back to let's create a new example. Example.doStuff. We know this is definitely not null, because doStuff returns string, not nullable string. I could do this and store the variable in a nullable string. That is perfectly fine. This allows to store values as complete normal string and allows us to store null. So we can fit the non-nullable string in there. You might also notice that this question mark here isn't fully visible. It's slightly grayed out, a bit obfuscated. Because my IDE knows I don't use the nullable feature, so it's not really needed. I can remove it and the code still works just the same. It's a different story if we say our doStuff method can return null as well. Now we get the error. Because, let's just compile it quickly so you can see it. Converting null literal or possible null value to non-nullable type. String is not string nullable. And doStuff method might return a full string. It does actually in our case, guaranteed. But the method signature indicates that technically we allow null to be returned from this doStuff method as well. And so our code has to be able to deal with that. We have to include a question mark in here as well to mark down that we do have a potential null value coming back here. And now in my code up here, I know that this might be null. You also notice that this question mark down here is slightly grayed out because I never return any null. Can change the code. Now it's fully opaque. Wait, it's opaque? Opaque, yeah, right. That's full opacity is opaque, right? Opposite of invisible? Whatever. And now this makes sense. String cannot be null. We're definitely returning a null here. So I set string to nullable. Pretty straightforward actually. This makes other code redundant. So if I were to check if doStuff is null, then I have to do some handling here for the case where doStuff is null. Now, right now I know doStuff is nullable, so this check makes sense. If it's not nullable, then first of all I can't return null. My compiler won't allow that because I can only return non-null values. So I can do this. I can return a string with the word null, that's fine. Return that here. And doStuff, well, I can also set that to non-nullable because doStuff never returns any null values. And my compiler notes that, hey, this if will always be false because doStuff can never be null. The code is still allowed. I can still write this. Like the check is fine. I can also do something like int a equals. Actually, can I do? No. Okay, this one doesn't make sense because it's value type, so it's not letting me do that. But this is still a carryover from the old system. It will still let me do this, but it's definitely showing me here. You can see the tooltip, but it's definitely telling me this is always gonna be false because it's never null. You can also go it's not null, and it will always complain that this is always true. You don't need the if. And this carries throughout the entire codebase now. If you have anywhere that's just a pure string without the question mark, and you pass it on, the entire rest of the code that uses that value, interacts with that value, knows it's never null. And throughout the entire way, throughout my code, I never have to worry about any exception handling for null references or any additional code that evaluates, is it null, do I have a value, can I get the length of this, or is it just null and nobody can exception it? I have to have separate branches of code where I have to make an if null, then do this stuff. Never have to worry about that. This returns a string. I have a string. I can do stuff with the string. It might be an empty string, but it's a valid string. I can use that. My code doesn't break because the logic always applies. And that's so convenient. It's annoying the very first time you try to use that feature once you're used to null, because your old code might need to be rewritten quite a lot. Especially if you make use of null for your logic, but since I started using Nullability as just, I start my code with that enabled always, and I write it with always that in mind, it's become so much more comfortable. Just being able to include a library that a colleague wrote, and I can be extremely sure about, this is null, this is not null. I need to include checks here for nullability, because this method is intended to return null, and that is intended behavior, and I have to deal with that. And this method is never intended to return null. The compiler assures me that this is not null. And I don't have to worry about that. I don't have to think about that. It's surprisingly huge workload that's off my table now, because the compiler will take care of that. There's a bit more about nullability that we can do though with special attributes that were introduced. Now these are not in the .NET framework anymore, just as this nullability is not in the .NET framework. That's a newer feature. The following attributes are also only for the newer C# languages. So if you're still trapped in .NET framework or an old C# just in general, I'm sorry, I'm gonna make you very jealous now, but let's say let's make a good old parse method. Public static bool, let's make a try parse. Try parse string s out int. Well, let's do like that. The code doesn't need to make sense. If s puts 1, we're gonna do some very simple code right now. Return true. Else, no, let's do 1. Let's make it sense. 0, return false. So we do it like this. Now this is just a warm up. We can do sample.tryParse 1 out int length. If successful, then output length. Else failed parse. Oh, okay, this is not really a parse. Try, let's rename it. Try do something. Doesn't have to make sense. And do console.readLine. No, not readline. Read. Let's read key. That's better. So makes sense for 1, 2, failed parse. So logic works out. Now sometimes we don't use integers here. What if this is another string? And in case of 1, Let's rename this to output. We output 1. And otherwise we output null. Well, first of all, null cannot be stored in output because it's string. Nullable is not allowed. So we have to turn this to nullable. Right? So this method at least works. And we can also skip this. When we change this code, which, because the out variable allows null in here, in the signature, we have to allow for null in here as well. Okay. Now let's say if try do something is successful and we get the value. And I want to not output the, let's do this, output itself, but the length of the output. Seems a bit convoluted maybe, but just recap. We have a method that has an out variable that can be null. But we have tight control over when it will be null and when not. If it's not null, we know output is not null, we return true. And the one case where it is null, we return false. So we can use this if here to guarantee that this code will only be executed when output has a value, has a valid string, and this code will only be executed when output is null. We already have that guarantee. But the variable itself is marked as nullable, as output could be null or could not be null. The whole logic about the return value of this method tells us exactly if it's null or not is not known to the compiler. It's known to us. We would have to actually make a separate if output is not null and do it like that. I know this is kind of unnecessary because it's never gonna be not true, but the compiler doesn't guarantee that. So this is actually an error. That's why it's red. But that's where the attribute comes in. And this is an attribute we put in front of the parameter. NotNullWhen true. This is a specific attribute that's usually for this type of method, which is not uncommon. These try do something. These, if you think mostly about try parse, that's not far off. You can do try parse, try serialize something, where you try to create a value, but you cannot be certain that it will work. And you actually have a Boolean that you get back from that method that tells you whether or not the operation worked and you did manage to create or read a valid value. And in all of those cases, we have the issue that we cannot be certain that Boolean, return Boolean true means we have a valid value. I mean, we can ensure that ourselves as programmers, but the compiler isn't convinced of that. With this attribute, however, on the side of the method, the compiler now forces us to keep that rule in place. I can't do this now. If I do this, the compiler will complain because I set output to null, even though I promised I would not do that. If the return value is true, which it is here, then output at that point is not allowed to be null. So the compiler now, based on this attribute, decides that in the branch where we return true, output is not nullable. It's effectively string without the question mark. Only in the branch where it's true. In the branch where we return false, we don't care. We can return null, we can return non-null, doesn't matter. All that this says is it's not null when. Guaranteed to be not null when return true. We can also do false, of course. In which case, this original code would not work anymore, because if we return false, when this is the return value, false, this parameter cannot be null. So this one is basically the structure you would see for try parse methods. But it's not exclusive to booleans. Return value can be other stuff as well. We could also do int, return 10, return 5, that, and okay, I was mistaken. I was thinking of some other attribute. Ignore the last half minute. I was thinking of another attribute. Okay, that's the danger if you're starting to use different libraries that include options that are not standard. You kinda forget what was in the basic system libraries and what you've added later on. Okay, so the basic system library has boolean. So standard bool something out. And because we have that attribute now, and the compiler itself ensures in this method already that we cannot return null when a true is returned, the compiler can also be sure that this branch where the method is returning a true cannot have a null for output. So this will always be a valid value. It cannot be any other way. The compiler ensured that this cannot return null. It's not just us as a programmer, it's the compiler itself that would not work otherwise. And so the compiler at this point can also rely on itself to do the job correctly and not return null. It gets a bit more complicated once you load in libraries from other compilers, so to speak. If you load in an old library, for example, in .NET Standard, where this feature doesn't exist, you would just get a string back, which is nullable, and there you can't rely on it anymore. And of course, I can technically ignore this completely, and yeah, don't think too deeply about it. This attribute, NotNullWhen, ensures that the Boolean return value is tied to the nullability, and so we can skip the whole null check because the compiler did that for us in here as well. So that's convenient. That parse and 1, 3 because 3 characters in 1. NotNullWhen. Let's do another one for Nullable, another attribute. Public string so right, should also mention that right now compiler will complain that length is non-nullable, but I'm never assigning it a value. If I just create a new example with the default constructor as it is right now, length would not receive a value. The actual data in the heap that stores this object would have just zeros in here, meaning length would be null. But we specifically said null is not allowed. So to make this work, I would have to either do something in here, initialize it like that, or I have to add it in an constructor. Either way works. Now it doesn't complain anymore. Or I could just mark this as nullable and everything's fine. Now it will be null if I just initialize it, like here. But that's fine. The compiler knows now that this is potentially null and it will know how to deal with that. But let's say we have public void length is a bad name. Let's do foo. Let's do good old foo. Public void set to something. Right, and this will set foo to something that I cannot write. Like so. Let's ignore all that. If I just call example as is, example.foo might be null. I mean, in this case, we know it's for certain null. And so I can't just go example foo.length. Can't do that because it might be null, and this will just cause an exception. But if I call example.set to something, once I did this, I know for certain that example.foo is not null anymore. It's guaranteed, it's not null. I can just call example.foo.length and that's fine. So doing it up here, that's an error. I know for certain foo is null. Down here, it would actually be fine. We know for certain as the programmer, again, we know it as a programmer, we set the value, this will not be null. The compiler doesn't though. Compiler cannot be sure of that. Just as we had down here with this system, by itself, the compiler does not trust us as the programmer. And it shouldn't, that's its whole job. It's good that it doesn't. But it can trust itself. So just like down here with the attribute, we can say that we want a special logic for this method, that this field will not be null once we finish calling this method. And this is an attribute we apply to the method itself. MemberNotNull. And I'm gonna do a name of. I could just go with a string. Ooh. This would be fine, but name of is better in case of refactoring, so I know exactly what's what. So if I change this, I will get an error here and I know, okay, I have to still change the value, and refactoring is automatically applied, so name of is the better option. Plus, it's all compile time change. It's not like your program is affected by that. The compiler will just take a moment to replace this with a string foo. It's not going to increase your compile time by much, no matter how many name-offs you use. There's probably some weird switch at some point where you go above a threshold and name-off would have a performance impact. That'd be interesting. How ridiculous would your code have to be to cause an impact for name-off? Like, how many name-offs does it take? Ah, never mind. So by doing this, I am telling the compiler this method has to ensure that once it's called, once it returns, the member, meaning the field or property called called foo, cannot be null. It has to have a value. And the compiler enforces that. If I remove this, I get an error. Member foo must have a non-value existing. So that's not valid. Or if I just set it to null, same result. It will not allow me to do that. This code itself is fine, but the method itself as a whole has to ensure now that we did provide a value for foo. And because of that, this code up here is now fine as well, because once I did this, foo is guaranteed to be not null. The compiler knows that, so my code does work out. Just compiles, it runs, perfectly fine. If I don't do this method, I get an error here because the compiler cannot be certain anymore that it's not null. In fact, the compiler would figure out that this is guaranteed null. I mean, it says possibly null reference. That's enough for it to stop. We know for certain it's not. But MemberNotNull, another attribute, enforces us to ensure our code here follows our logic. And because it enforces the logic here, the compiler can be certain that it was followed up here. So another attribute just to help with nullability. These two will be your best friends, NotNullWhen and MemberNotNull, the two most important nullability attributes that you're going to work with. There are some variations on some other types, some other attributes for nullability, but honestly, I don't think I've ever used them. It's only these two always. Right, so far for nullability. Took long enough already. I might have stretched this part a bit too long. But it's a cool feature. Like seriously, I was so happy when they introduced this. You have no idea. It's fantastic. I really like the new nullability, well, new quote unquote. It's also in there already for a few years. But since we have the example class, let's do some other stuff here, some other attributes. There's one attribute that we we could have used several lessons ago when we were talking about sets, hash sets. And that was because it was just a little side tangent, but in that custom set we built, was it in the dictionary? No, I think it was in hash set already. We had an internal struct called item. Something like if we had an internal struct here, not string, struct item. And the whole thing itself had an indexer. Public, let's just string this and index something like this. And that had an error, with the exception, well, the error being there's already definition for item. Because the indexer internally uses a special item that the compiler will add to make the indexer work. But now we have the struct item and the special member item that's used for the indexer, and that's a conflict. Two different parts of my class example have the same name. That doesn't work. And the way around that was to rename item to something else. But there was another option we can use. And I think I mentioned that, but at that point you didn't know what attributes were, so I couldn't show. But the alternative would be to use an attribute on the indexer, and that's just IndexerName. By default, it would use the name item. So basically, this is what would be the default. The special member that is used for the indexer is usually called item, but we can give it any name we want. And this is now used by the compiler for this indexer in this class. Can do index, cool, okay. Whatever. Different indexer, can have the same name, cannot have item. So could also do 3. And this would be an issue now because indexer, but suddenly you have 2 different names. So item, is an issue because we have already an item. Item 3 is an issue because, well, we have two different indexer items now. 2, that works. It's the same name. If I remove it entirely, we get back to the original issue and the new issue. Usually this is not happening. I mean, it's rare that you have multiple indexers, probably. In that case, at least IndexerName is fine. And you can always use, well, it's private const string, right? Like this, and then have a separate indexer do the same. So you don't have to worry about the name being different. But that's what you can do there. But this was for struct, it's for members in general, so I could also not do public int item. Doesn't work. Item as the name is just blocked for the indexer, unless you use the attribute to change the name for the compiler. Another attribute you've already seen was flags for enums, which just marks it down as this enum can combine different names for different values into one value. It represents binary flags, and we can combine different values in a single integer because every single value in our enum represents one bit position in the entire number. I'm not gonna go over that again. But flags, another useful attribute. Then no, let's do that one last. I swear I just had it. What was the... Oh, right, that one. So public int count like that, and bring this. For some reason I really like strength and length today. Actually, let's skip the whole part here and just make it static. Let's make it easier. So example.getCount. Hello. A simple method that simply counts. Let's remove this one. That simply counts how many characters are in a string. Let's say this is part of a library I'm writing, either for myself or for someone else. And at some point I decide there's some major refactoring necessary, and this method doesn't quite cut it anymore. So maybe I want to get count, but or well, let's say skip. Look at that. I wanted to count, but I wanted to skip a certain number of characters first. And yeah, that's just subtraction in the end, but let's say I want to expand this. And actually it's not purely that, it's length greater than skip, then 0, otherwise greater or equal skip, otherwise length minus skip. That's a little more correct. We cannot return negative values, so it's not straight up subtraction, but this would be the new definition. Of course, our old code now doesn't work anymore. We changed the signature. That's not too good. It's a simple fix. This was the same as just calling with 0. So something I can do as the originator of this library code, I could make this just optional, in which case this old code would still work. The only downside is this only works if I'm directly using that library. There's actually some weird things once you have an indirect dependence on a library. Like, I wrote this code, someone else wrote a library that uses my code, and a third person uses that second person's library in their code. So we have program A that uses library B that uses my library C. And if I change the signature in here, even if it's an optional, it's still a change in the signature. We have suddenly an additional parameter in here. And the first person makes an update of my library that they only have an indirect dependency on. Suddenly the second library, the first directly dependent library for them, the one the other person wrote, the second person wrote, their dependencies don't match anymore because their code assumes I only have a string. And once you try to compile and run everything, it will complain that there is no method getCount that accepts just a string, because I always have to accept still an int, even though it's optional. So optional variables are useful in your own code, but if you write a library, there are still some caveats because of dependencies. So in those cases, even though it's a bit more work, it's better to write just an overloaded method. Count s0 like that. Same effect as with the optional, but now we have the original signature, the very first signature we wrote, still there, and our code can still use it, and everyone that's dependent on that signature will find a match. That's good. And we don't have to write a second full method, we just have to redirect it with the optional values to the other method. And if the compiler is set up right and everything works normally, this doesn't really have any impact on performance. It's sometimes completely skipped and the compiler will just merge everything together. Depends very much on what you compile for what in Black magic, I tell you. So this way we can upgrade our library without causing issues for someone else who uses our code. We kept backwards compatibility. Old code that uses the old code from us still works. Programs that use our old version of the library work, but people can also use our new version of the library, which has some new features. Both still work. Someone can just upgrade to a new version of our code, and their old code still will work. What if now I decide to change this completely and I make major rewrites and I don't have getCount anymore? I now have a method called public static long count characters from list. And then string input and char. What do we call that? Loud? Okay, doesn't make too much sense, but let's do it like that. And long counter 0. Good for each. If dot contains C plus counter. This is not very performant code. Also, this is a link expression. We talked about those before, so it's just a simple helper method that will effectively just go through the entire character array aloud and check every single entry for, is it this character here? So performance-wise, not good code, but perfectly fine for our explanation. And actually, if those two are short, well, on the short end, especially if allowed itself is a very short array, this doesn't really have any larger performance impact. But you certainly can improve the performance. Let's not talk about that. Let's say this is the new way my library works. We can't just count characters anymore. So the old code doesn't work at all anymore. Even just adding parameters doesn't work because we use a completely new name. The signature has changed entirely. We have a new return value, we have a different name, we have different parameters. Maybe this isn't even static anymore, and the new one is based on instances we have to tie it to. Maybe this character allowed is not from the arguments here in the method. Maybe it's stored internally, or maybe there's some other data internally stored that I have to provide first. Changes like this are definitely backwards breaking. If you do something like that in your code, in your library, it will screw over people that depend on your old code. And that can be a pain to deal with. There are ways, however, you can make this easier on them. First of all, don't just straight up delete the old version of your code and replace it with a new one. Sometimes that might be unavoidable, but ideally you keep the old code still in there if possible. That's not always possible, I get that, but if it is possible, leave that in there. And to make sure that people know that your new code uses this method and these are just in there so it doesn't immediately break their code, but they should not use them anymore. And please, if you write new code, do not use these methods, even though they are still technically there. You use a special attribute called Obsolete. And Obsolete has a couple of parameters, but for our case, we only care about the first, let's say first two. First is just a method, auto do not use. We just write some message to people telling them this is not to be used anymore, please use this other code. And you can also include things like, hey, go to this website to check the transition, check the new documentation, steps to do, steps to avoid, examples, or just a simple, hey, go to this other method and look at that. But just some basic instructions that use, I mean, you can include something like, wait, couldn't I do this? Yeah, no, I could use it. List. I was about to say, the string interpolation works now too for the constants in the new C# versions. Before I would have to use string concatenation, like actually make a new string and then plus and whatnot. But this works now too. And again, I just use name off because it's more convenient, so I immediately know if I break something and refactoring is easier. I could just do this. I do that for both. And I'm not including any this is not a good statement, but it's a statement. My get count up here, you can see it's highlighted in blue now, and I do get a tooltip. If I compile, you can see a warning in here. It's obsolete and followed by my message. So if I compile my code, if I have a large code base and compile and I see this warning, the specific warning code and it's obsolete, I know, oh, I updated to a new library today and suddenly I get this warning, so I probably have to do some refactoring because there were important changes in this library I just imported. But the old code still works. So that's the good thing, that's what we want. We gave them the information that something changed, so they are aware that they need to adapt their own code. But they can get something working immediately. It's not we broke their system entirely. That's the best case. We have the old code still working, but we made them aware that there are changes. Alongside, of course, usually some announcement on some external resource where we provided the code. That's how I usually do it. But you can also go a step further. Let's say we don't want to support this old code anymore. Maybe because there are some critical flaws in here. Maybe there are some critical bugs in this code that make it completely unsafe to use, or it's just entirely impossible for us to support anymore for some other reason, because this uses internally some code that we don't have anymore after refactoring, whatever the reason is. You could just go, we had another parameter here, and set this to true. We mark it as obsolete and tell it to mark it also as an error to use. Now I can see I have a red highlight here, and if I compile it, it will not compile. It's an error now because it's obsolete. It's same as with Nullable earlier. I can have it just as a warning, or I can have it as an error, depending on how important it is for us to prevent someone from using it. And in case of this is permanent error, to avoid them sneaking around it, we could also just use our code with just the signature and fill in the gap with just dummy values, like a 0. So the old code simply doesn't exist anymore. We left the signatures around, so we have something to mark as obsolete, and so their code shows exactly where it's obsolete with the information how to change it. If I were to just remove the code directly, which might be necessary, sure, then I just have, this doesn't work anymore. There is no method getCount. There's no confusion, and this is not very helpful to the other programmer because they might assume that, okay, this is from that external library I loaded, and this method doesn't exist. So did I break anything on my end? What went wrong? Is just the update itself that the method doesn't exist anymore? Not the most helpful. So having an obsolete method, even if it's a dummy method without any actual content, preferable. If you can keep it in there, at least for a couple of updates after you made the change, that's a good thing. At some point you should remove the obsolete though. Just remove the old methods completely. How long you keep it in there is entirely up to you. I mean, these couple of methods in here don't really hurt me, don't really hurt my library in theory. Unless, of course, I want to reuse the name for some newer methods, in which case things get even more complicated, but that's a completely different topic. So, obsolete, very useful just to mark down that a method is not used to anymore, and you should probably change, or to just help people when they absolutely have to change, in the sense that they can see the error, they know they have to change, there is no choice anymore, but we give them some more useful output for it, which makes the transition a lot easier. So that's obsolete. Let's go to the next one. Let's say we have, let's do string, I said string name, and we have private int ID and public example. Yeah, let's do like that. Sometimes the autocomplete is smart. Sometimes. Example bar 3 ABC. Wrong way around. Actually, no, let's switch this around. Gee, do I have still the shortcut? I do have the shortcut. Haha. Well, not that it really mattered, but it's not switched. Okay. I'm just messing with the refactoring tools I have here. I have now an example instance that publicly has the variable name, and internally has also the variable ID. And let's say the name is just for users to display something, but they don't really have any relevance technically. Whereas the ID is the one I care about on the inside internally, that has meaning. Now the way I use this, I'm not sure how to phrase it. Let's just start again. Let me just demonstrate. Let's just have a look. I'm just gonna compile it with the debugger. If you look at the debugger output I'm presented here with, look on the right, example is a curly bracket example, which is just the type. And if we look down here in the debugger view, on the locals list, we have the variable example, which is of type nothing and more dot example, so namespace dot class, which is correct, example, and the value shows, well, just the type name again. And actually that's the same we would get from the toString method. So if I run this code, we see the output of toString is nothing and more dot example, which is the type name of our variable example. That's the default toString method. And that's what the debugger would show. So I can just override the toString method and return name. If I do this now, we see that the debugger shows us ABC up here, and the toString method is ABC. And down here in the debugger window, you can also see it's still type nothing and more dot example, but the value shown in example here, the summary basically of this object is ABC. You can look inside and see, okay, ABC is the string name and the integer 1234_ID. But cumulatively, the debugger just shows it as ABC, which is a bit more interesting to look at if you look at the debugger output than just the type name, which we already know. But I mentioned earlier, the name is just what we show outside to a user maybe. So it might make sense in the toString method, but for us, it's more interesting what ID says. So what I would like to see here is the ID. So I could change the toString method to output the ID instead. That works, but the internal ID is not what I want to use for the output to users, so the toString method should not show it. That should not output that as a string anywhere. That's just nonsense. So I want to have the convenience of having the debugger show me something useful instead of the name, so I can just have a quick look through the output in the debugger. While I want the normal functions like toString to still use something sensible like the name. That's irrelevant for non-developers. And that's where we have this beauty here, DebuggerDisplay. I'm just gonna do hard-coded string like this first. You can see, wrong breakpoint. Let's put that here. String, ABC, that toString, but the output for the debugger is foobar. So we separated what the debugger uses and what the toString returns. The debugger doesn't use the toString anymore to determine what to show in its output here. Same up here above. And we can actually include actual data from example. Now this is gonna look a bit weird. We are technically not inside the class, but we are still able to use features of the class. And furthermore, this is like an interpolated string, but we don't add the $sign in front. So that's why this might look a bit weird. It is a special feature. but I can do this as if this was an interpolated string inside the class. So I can include these two properties, or these two fields, and generate a string with it. And if I run this code, the debugger will show me 1, 2, 3, ABC. So it will even add quotation marks around the string for convenience, so I know this is a string. And to the outside, for toString, for user interactions and whatnot, I can still use the toString method to generate nice, convenient ABC, which is just for output. But I, as a developer, looking just through my code very quickly, can see, oh, 1, 2, 3, that's the internal ID, that's what I care about. Which is also referenced as ABC on the outside. If I do a separate value, example 2, like that, I get a different output. So I have 1, 2, 3, I have minus 8, 5, 9. Just a very simple way to make the debugger output a bit more useful, maybe. And in this case, it's just the naming toString method. Generally, you can always override toString. Like, if you write your own classes and structs and whatnot, overwriting toString is probably a good idea, because toString is used in a lot of cases as a default output. But for the debugger, the output is probably not required that way, because in the debugger you have a direct reference to the object already. You are in the debugger, you're looking at a specific variable, so you already have a lot of context data based on just your debugger. And so in that case, you want maybe just 1 or 2 specific pieces of information from that entire object displayed as a cumulative overview of just a quick, oh, this is this ID that I saw in my database somewhere else. I can reference that. It's just a quick summary that's useful for a developer while debugging, and that's different from a full string representing the object like toString. So DebuggerDisplay, don't use it too often, but I find it to be quite useful sometimes. Hi, I'd say it's going quite well. Yeah, I mean, technically I didn't learn OOP originally. I started with basic, or with a basic variation that didn't have any objects. But I think when I really started programming, that was with Java. So I do think I would, yeah, I think I started with OOP for real programming. You want to do a little quiz? Sure. Not sure when you want a quiz. If you're a C# programmer, there's probably not much I can answer that you couldn't answer yourself already. And yeah, I'm by now C# developer. Just my beginning was with Java. That's where I really started going off. Okay, we only have 1 topic left. Yeah, let's put that back. Alright, we're gonna do a little quiz then. What's your question? What tests do you provide me with? Can you explain OOP pillars? I don't think I can, because right now I'm not sure what that's supposed to mean. Pillars, like the pillars of object-oriented programming, like the fundamental ideas behind that, or? I mean, there was something for the, here are the fundamental rules for object-oriented programming, and we usually break those rules, something like that. Can you explain? I can try to explain those terms as far as I understand them. That's helpful to you. But I'm probably not providing the answers you actually need. Not sure what context you're referring to these, but okay, let's just put them down quickly. We have encapsulation. Abstraction. Then we have polymorphism. And inheritance. Encapsulation, just, yeah, wrap the data or wrap something in something larger. Either to make it more easy to work with, if it has a lot of rough edges and a lot of specific rules that make it difficult to handle directly as raw information, you might want to put it in some shell and some surrounding wrapper that kind of deals with the little rough edges, the little details that you have to take care of all the time, and makes it just more convenient for someone on the outside. That's what I would think. Also helps with the, later with the, well, actually they're all connected in some way. Abstraction is just, I don't care about the specifics, I just care about some general idea behind it, some general functions, abilities, properties of something. And it's more like the rules I apply to a group of something, and within this group can be many, many different things that work very differently, but share properties or behavior that I can apply in a generalized way. Encapsulation is more of like getter and setters. Okay, so you mean I don't get direct access to the data, I have to go through an interface to get to the data. I have to use a getter and setter to make sure that my interaction with the fundamental data is following certain rules. Is that what you meant? With encapsulation is more of like getter and setter? Abstraction is more of like abstract class and interface thingy. Well, yeah, I provide the general behavior that many things, or I determine a certain amount of, define a certain behavior or property or group of behaviors and properties, and there's a larger number of things that all share that. And so we apply that, which is a polymorphism. Because of abstraction, I have these very specific things as actual data somewhere stored, but the way I interact with the data is in this very generalized way, this very abstract way, because I don't care about the specifics, I care only about one specific property that it shares with a lot of other things. And so, even though the data internally is one thing, I can share, or I can store it as some more abstract thing. And the compiler will let me do that, because internally, I mean, that's compiler magic. In the end, it will still know what it's actually, but as far as I as a programmer is concerned, it suddenly changes type from this very specific to this more generic thing. Polymorphism have things like static and dynamic binding. I have to think about what that means, to be honest. Static not dynamic binding. Like, I know there was dynamic stuff. I had dynamic. I've always avoided it. There was some time when I was kind of forced to look into that, but I didn't really need it in the end. Like I was trying to solve a problem, and the examples I found online were always talking about dynamic. Like dynamic keyword, and then, dynamic objects that I would have defined at runtime, the properties of an object. I don't have it at compile time, the definition of what this object looked like. And instead, during runtime, it would apply these rules for a completely runtime constructed class. Runtime and compile time polymorphism. Okay. Yeah, I think that's a lot of stuff I don't know. Inheritance. Yeah, it all comes together. In my head, these are all terms for basically the same principles. Inheritance just... I have a certain definition for a class somewhere. I have one type of behavior or property, and I want to take the same behavior and properties, but use it for something that has additional behavior and properties. And instead of rewriting that completely and make a complete copy of that with just additional features, I have the computer just stitch them together. I just have take this original with all its behavior and properties and just pretend like I have all of that and add my additional stuff to that. Like take this original, my base class, and then create a child class that has all of that plus this additional stuff. Method overloading is static time or compile time. Yep. And method overloading. Method overriding is compile time polymorphism. Huh. Method overriding. Compile time polymorphism. I have to really think about what I personally think of static and dynamic. Like, I don't think I've ever thought about that. Or I had to think about dynamic and static. Like, that's an entire branch in C# that I never touch. I mean, specifically dynamic, that's called out dynamic, but... Can check with the GPT. Oh, no, I don't trust GPT. I'll be honest, I hate using AI for programming. Sometimes it's... I've tried it a few times. I think over the last 2 years, I think there were 4 or 5 times I tried an AI, a couple of months in between. Just open the AI, just give it a couple of questions and trying to see what it's outputting, and it's impressive, but I was never really satisfied. Like, I always felt like either I'm dumb and I'm asking dumb questions, or you are dumb and you're just giving me dumb answers. I don't know. It was always kind of uncomfortable, and I never got really what I wanted from the interaction. Plus, there's too much stuff I've seen with AI code that makes me just go, I do not trust this a bit. So, doing a solid principles, solid programming. I mean, I've heard the term. I'm probably using some of that during my normal time because I'm kind of grown into it, but I don't know what the principles themselves really are. Like, I don't have... I'm not sure, maybe it's just the way I learned that stuff. Just, hey, here are things you should do and not should do in programming. That's what I was taught. And then later, oh yeah, there's a name for this, actually, and this is a general term for programming in general. Oh, good to know. Favorite design patterns. Favorite design pattern. Do I have a favorite? Let's see, what design pattern do I use most often? Maybe that's a better question. I mean, recently I had to use a lot of... No, that doesn't count. I was thinking singletons, but no, that doesn't matter. I had to deal with a lot of dependency injection. And that sometimes is useful. But the current frameworks are kind of a pain to debug, I find. That's a downside. For a time I got interested in nomads. But that didn't really turn out to be useful, at least in the code I wrote, so just dropped it again. Factory. Oh yeah, factories. Haven't used them in a while. Although, I mean, I do sometimes use a sort of cheap factory. Like the very, very simple, I just have a static method that does everything for me and don't use a constructor anymore. No, I don't use that. Template? Did I use templates? I think No, I tried at some point. I was hoping to use templates, but that was overkill, and so we dropped that. Just not necessary anymore. Like sometimes your code already works, and adding some new pattern to it just not worth it. Makes just everything more complicated if your code is already doing its job perfectly. So single responsibility. So it's just an acronym for specific principles. These sort of principles. Substitution principle. Let's see. Can't say I'm familiar with those terms. I don't think I can consider myself a technical programmer. Like, there are a lot of rules and terms and all this theory around it, around programming and all these If I watch a talk about, or if I hear some other programmer give a talk or show something and then they throw out these two cool concepts and ideas and names for everything, and I have no idea what you're talking about. And then they show the code and, oh yeah, that's what you mean. Okay. Interface segregation principle. See, I know the words and I can guess the meaning, but I just write my code and I know if something looks weird and I don't like it, and sometimes something looks good and I like it. I can't really put into words why. Usually that's how it's always been for me. That's also how we usually do it at work. Like, none of us really use any terms. We just... certain ways of coding just work out well, and we know we can do it this way and just use a class that does this and then combine it with some interfaces here to make that part easier. Why static and main method? I mean, technically there's no reason why they couldn't just enforce some rules that you have to create an instance of your entry class. Maybe there's some underlying code that's involved with instance management or construction that they don't want to initiate before they reach the entry port of your code. Because static methods don't really need any instances, and it's easier to initialize the runtime that way. I absolutely can see the option where they have a rule, hey, you have to have a main class that has to have these conditions for their constructor. I mean, technically constructors still count, right? I still have a static constructor, so having a normal constructor would still work. Either it's some compatibility issue across .NET runtimes in general, or it was a consideration to simplify the initialization process, so you don't have to run constructor code before you have any code. I mean, if you don't like the static main method, what was the new setting for .NET? Was it top level statement something? Where you can remove all that stuff and you start with just an empty file and directly write your code as if you're in the main method. So they hide all that stuff, so you don't have to worry about it and think about it anymore. Don't like that. We use it for we had one programmer in our company that developed some code with that, no top level statements, and we still use that code a lot. I don't like that. I'm very comfortable with having the structure. I have a namespace, I have class, I have a main method in there. I like that. It feels comfortable, it feels safe, it feels like I know what's going on here. I hate it when the entire code is just magic and there's a lot of stuff around it. You just have to remember that there is stuff around it. That's the same reason I don't like the dependency injection weights framework. It's like we have ASP.NET Core program, and it's so convenient to use. I get that. Like, I just create the object here and put it basically in some mystery cache in the background, and some other classes I just say I need an object of this type, and it will construct it with the data from that cache, basically, and it's great, it works. But it's a pain to debug when you want to find out, why did this value appear here? This object was created with a wrong object. Where did this object come from? Where was it created? Why was it created wrong? And then you have to figure out, okay, where in my code do I create types of this object and add them to these cache in the background? And it's, I hate it. Wasted so much time. You know, linkpad doesn't tell me anything. Is it like an editor? I mean, link sounds like link, that LINQ, but I'm not sure what linkpad is. Playground. Oh, it's something like so basically some documentation with a built-in compiler and runtime. So something like, here's some example code and you press a button and try it yourself. Books. I'll be honest, I don't think I read code books. This is too boring for me personally. Plus I'm always afraid that I'm reading this book and it's outdated already. Code blocks? I mean, I've seen stuff where you have just a website with documentation and tutorials, like actually written out for a human to learn. This is that, this is doing this stuff. And then you have these nicely syntaxed segments in between with example code, and you can press a button and you just run the code and see the output, and it lets you actually edit the code and changes to see how it reacts. Like, I assume you're talking about something like that? I mean, stuff like that, I probably look something like that up for new language versions when they come out. Like, new C# versions out. Okay, what does it contain? Show me everything that's in there with examples of what I can do. Okay, linkpad. Yeah, we'll do after stream. I don't like doing stuff like that while on stream. Not my style of streaming. At least not for this type of stream right now. Technically, this is supposed to be a lesson. Technically, I mean, still a stream. And for MS docs, depends. Like, if there's a new language version out, I do check the MS docs, because they are the main source. So I check out what features do you offer, and if there's specific new class or something I find interesting, I check out the MS docs. What do they list on there? Like, do they have interesting remarks, so things I have to look out for? Any gotchas? Some example code maybe? And if that's not enough for me, I usually just go to the, source.net, look at the source code, try to figure out what it's actually doing. Like, I'm not using the Microsoft Docs for general learning, but more for, here's this very specific class, give me all the information you have about this one class. Then I, sure, go to Microsoft Documents, documentation. I find it to be quite useful. Also, I like it. I look it up quite a lot. When I want to have some overview over general usage of that code and what can I do with this, better strategies for using these classes and combining them and doing what I need, then yeah, no, I don't waste my time on Microsoft. I mean, in the end, after Googling it, I always end up on Stack Overflow 60% of the time. Or one of, I don't know, 5 blogs that exist around coding that somehow have all the answers to all the problems I ever come up with. Oh, where was I actually? Wait, or was it debugger? Right, the last one. Still want to get the last attribute finished. I'm gonna check that off my checkbox today. I'll have to show something else first. So, in C# we have this little feature that's more pronounced in other languages. Like in C, it's a full-on scripting language. In C# we only have limited functionality, but we can do stuff like this. We can create, if we start a line with this pound symbol, the hashtag, we can create a simple logic that checks if a certain flag is set. And we can also use it to set those flags ourselves. Will it just, is it set? Is it not set? And the name can be basically anything. It's usually always uppercase. And we have the simple logic, just an if and if logic. So we have if to start a block. We check if this flag, whatever it's named, is defined, is set. And if true, then the next part of whatever we write in here is considered by the compiler. Yeah, thank you for joining in. Making this a bit more lively. Have a good one. And all of this will continue until we hit an endif where we will end the block. So everything I put in here is only considered by the compiler if this flag exists. So if I do this down here in my code, I can do this. And it will just consider this as code to be compiled and executed. So if I run my code, flag is set. If this flag is not set, or if a different flag is set, for example, you can see my code right now is grayed out. So my ID will automatically react to this not being set. This is certainly not true. This flag isn't set. This code will be ignored. It's right now just text. It's almost as if this entire thing here is just comments. The compiler will not proceed to use it. It will just completely ignore it. So if I run this code, there's nothing to show. There is nothing. It's an empty main method. I can also chain these together. Something 2. And do another define in here. Something 3. So something 2 is set, so something 3 will be set. Can also go for something directly. There are also things like elif to create an else if statement, or just an else. And that's basically the same if, else logic that you know from the normal language. And all of this is just defining if there's a block of code that's used or not, with just a simple if and if. And this is useful because you can control with just a few lines of code at the top of your class, for example, if a larger piece of your code will be used or not. And if you're now thinking, why would I want that? Well, if you look at the top here, I have this little selection in Visual Studio. Right now it's setting debug. You can also change it to release. And this has a lot of effects, but the one we care about right now is that depending on which one I set, there's already a flag defined, a set in my code. When I have debug selected in the top, then I have this flag set. You can see the code is valid because this flag is set. If I change to release, it's no longer set and this code is suddenly invalid. Can do the same with release. Release is now set. If I change it to debug, it's no longer active. And there are other features, of course, you can enable and disable, depending on your circumstances. For example, you can write code that will behave slightly different depending on what target system you compile for. That's a larger topic, but while technically .NET runs on a lot of operating systems and under a lot of different circumstances, there are small differences in your code that we have to make. And to make life easier, you can use these precompiler statements to split your code into parts that only react to one specific type of, let's say, target platform. And most of your code will just stay the same. You just have to compile 2 or 3 times, and each time you just set a different flag, and everything will just work out. And you don't have to rewrite your code constantly or keep track of 3 different branches of code. Most importantly, however, is for debug, you can add additional output to your code, for example, for logging. And you can have normal output that you want in any case, not just in your debugging context. So while I'm developing this code, I want to write normal output as it's intended, and I want this additional debug output, but only while I'm developing. When I finish my product and want to ship it out, I usually use the release build, which has, again, other consequences. For example, optimization happens, and then I don't want the debug output because the end customer cannot make use of that, and it will probably just stop performance a bit or have unintended side effects. A lot of things that you don't want to happen in release code, but that you absolutely want in development environments. So we have these little statements which you can use to turn them off or on. There are, by the way, other precompiler things we can do with this hashtag symbol, pound symbol, but the most important ones are just define, to set a flag, and this if, elif, else, and if, to react to that, to turn off certain parts of your code depending on your settings. But there's also undef, which turns a flag off again. So that way you can actually make nice change where turning one off will turn another on and whatnot. It's still further rather limited. If I think back to C, I can make complete programs just in precompiler statements. There's a nice comprehensive language basically, which does have its downsides because it can make the code harder to read because it constantly changes depending on settings. So it's a trade-off. I do miss macros. Anyway, let's say I have specific output that happens at various points in my code. Like I access the logs, or I do some performance checks and write them to logs and do some additional stuff. I don't want to write that code every time in my main code here. I want to put that out into one debug code to its own method, and I can just call this code in here. Right, and I can do that again here. Okay, static. Like so. Then here, debug stuff. But that means I have to add another if, of course, debug, like so. And be done with it. Let's make this a bit more concise. Can run this now. I'm in debug and I see debug stuff, normal output, debug stuff. And you didn't see it because console was too fast. Console dot. I can't type today. A read key. Let's try again, like that. Now if I try to do that in release, see, it's grayed out. This code is not real anymore. The compiler will ignore it, and only this line and this line will still apply. And let me run the code. Not sure if it's showing up. Okay, it doesn't show up because it has a different title now. Okay, so you can see it, but it only showed normal output. Actually, can I do this? No, okay, no, it's not letting me. OBS isn't set up for release builds. It doesn't recognize the console output anymore. I was too strict with my filter. Anyway, yeah, as expected, this is not code in release, which is correct. We don't want that to happen. But right now we have to add this statement around it every single time, which is a bit annoying. And also a potential source for errors, because let's say I change the flag I want to react to. I forget one. I change it everywhere except for this one, and suddenly it's gonna get executed in my release build maybe, because I didn't change everywhere. And even if I do have everything correctly and I was diligent enough to add this if and if everywhere where call run debug code, it still means I'm compiling this entire method and add that to the release build. So I would have to also add this check around my method, so I can be sure that the release build does not have any of my debug code, which could be exploited for security reasons maybe. Like if there's exploit you can do and with this code in there, you don't want that. Right? Or you just want to keep your code size a bit smaller, which doesn't really matter nowadays, but So you would have to add all these ifs everywhere in your code. And if you want to quickly check something or change something at your code, well, if I turn that off, my IDE doesn't recognize this as normal code, and this is just some text. So once I turn it back to debug and it will start to compile it, suddenly it notices all these errors. Not nice, not nice. Ideally, I want to have all the advantages of basically wrapping all of this into a debug, but none of the downsides. And for that, there's another attribute. And this attribute is called Conditional. And you just provide it with a string that you would usually put in the if for these. And I can now remove this entirely, and it will still behave exactly the same. Right now, I'm on debug. So all of this code is just in there and will get executed just fine. But once I change to release, notice how my lines change in my compiler right now. My output window. See, they get a bit phased out. Because right now, these are not actual code that I will compile. These are not included in the finished program. There are lines of code that are written in here, but they're not actually executed. And I can actually see that with a tooltip. Once I hover over here, you can see the tooltip. Again, OBS isn't set up for that because I was too strict with the rules. I think I want to keep the rules though. But it would not be compiled with it. If I run the code now, and even though you can't see it, I only have normal output in here. Not the run debug code. So this conditional allows me to write the same code as before, but without all the precompiler instructions. Very useful. Meaning I have the full power of my IDE to change this code however I want, with instant reaction for compile time. The compiler still checks that everything is correct. Any change in here can be trickled down. Do you run debug code again? So refactoring makes no problem anymore, because the IDE can properly recognize this is a method that's called here and here. You can see 2 references because it tracks everything. I can also make changes quite easily like this. Still int number debug stuff number like so. Just add it in here, compiler complaints, because I haven't updated those 2. Wouldn't have happened with an if I just said this. Yuck. Well, this would not be code and it wouldn't have complained about it. So I just refactored this to include a non-optional integer, and it wouldn't have complained. And once I switched my definitions, I suddenly would have errors everywhere in my code, because I forgot, oh, I have to update this as well. So conditional is to be preferred over just precompile instructions, but it depends on exactly what you're doing. So right now, this might be check the condition of my entire code, maybe check memory state and how much memory I'm using, what is my CPU time, what's the state of these variables, and what are some other features I want to know, call stack, current state, and all of that. Put that all together, put it in a log file somewhere safely, and then continue with my normal code. That's stuff I don't want to happen in release mode, because I don't want it to happen on the finished program on a customer system. That's why conditional, which again applies just to any flag you set. Usually I only have it run for debug. That's what I always work with. For exactly this case, for debug output, I have entire logging systems that get only enabled once I'm set on debug, and once I'm back to release, the entire code is just completely taken out of my program. The entire additional layer of debug, logging and whatnot is completely gone, which is extremely useful. So that's the last attribute I wanted to share with you, conditional. And with that, we are done for today. Your homework. I want you to write one class that contains one example of each of these attributes at least once. All of the attributes we did today. Which also means you will have to turn on Nullable. Once more, this is what the code looks like. To turn on Nullable, if it's not already enabled for your .NET project, we have the property Nullable, which is set to enable. And we want, this is optional for you of course, but I recommend you do it, the property warnings as errors, which contains the Nullable warning as an error. That's how you turn that on, and then create one class which has all the attributes, usefully, of course, which means you also have to contend with Nullable. Alright then, that's it for today. See you next time.